Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do a very important lead code problem, unique paths, and as you can see that this question has been asked in Google, Facebook, Amazon, Apple, Microsoft, Bloomberg, all huge gigantic IT companies. So I highly urge you not to miss this video and try to understand the problem as thoroughly as possible. This is going to be the framework for the video. We are going to understand the problem. We are also going to find a primitive approach. We are going to find the optimal solution, and we'll write a Java code for the optimal solution. This is a Leetcode medium problem. We are given that there is a robot and an m cross n grid, and robot is initially located on the top left corner. Now robot tries to go to the bottom right corner. So this is the last place where robot wants to reach. And at any given moment, robot can only make one move. It can either go down or it can go right at any point in time. No other ways it can make. So in the problem, we are given this m and n, and we need to find that how many distinct unique paths can robot take to reach to the bottom right corner or its final destination. So suppose our given m is equal to 3 and n is equal to 2. This is one of the test cases. So if we draw it on the board, it would look like this. This is where the robot is initially. So I'll just mark it as R, and this is the destination that robot wants to reach, the bottom right corner. Now we know we need to find that how many unique paths exist. So let's see that how many unique paths can we make. And at any given moment, robot can either go on the right side or down. It cannot make any other steps. So let's see that what are the possibilities. So this is one possibility. So this is one path. I'll just mark it somewhere. Now this is second path. I'll also mark it somewhere. So this is second path. So have we exhausted all possibilities? No, there still exists a third path, and the third path is like this. 1, 2, 1. And apart from these, we cannot make any more paths. So essentially we are exhausting all the possibilities, and we can return that for this given m and n, the number of unique paths can be 3. Now I hope that this makes problem statement more understandable. Over here initially we are given an example of m is equal to 3 and n is equal to 7. And the number of unique paths they get is 28. But the thing is, this would be such a long example, so I'm not going over it. Okay, let's understand this with a custom example. So suppose our m is equal to 3 and n is equal to 3. So we would have a grid that looks like this. Here, this is our robot, this is our destination. Now we are going to calculate that in order to reach to any element, how many unique paths we can take. So suppose if we want to reach to this element, how many unique paths we can take? We can only take one unique path, and that would be to take this right step from here. We cannot take any other step. Same goes for this element, that we can only have one unique path, and that would be to take 2 right steps from here. We cannot reach to this point any other ways. Same happens for these 2 elements as well, that we can only take 1 step down or 2 steps down in order to reach to these 2 elements. The thing is, there cannot be any other unique path if we want to get here. But the thing is, when we get to this middle points, something interesting happens. And the interesting thing is, suppose we want to reach to this point, how many unique paths we can take? Well, we can take 2 unique paths. We can take 1 unique path to reach over here and then over here, or we can take 1 unique path to reach over here and then again reach over here. So we can say over here we took 2 unique paths. But the thing is, if we just see that what are the entry points to get to this point, actually there are only 2 entry points to get to this point. One entry point is that we can, if we somehow get to this point, we just take 1 step downwards, we come over here. Or if we somehow get to this endpoint, if we take 1 step on the side, we reach over here. Which means that whatever the unique paths we have at these 2 locations, if we just sum these 2 up, it will give us the number of unique paths we can take to get to this point. So let me show you by another example. Now again, let's consider this element. So in order to reach to this element, there are only 2 ways we can reach to this element. We can either take 1 step from here, or we can take 1 step from here. Which means that whatever the number of possibilities we have over here, that once we get to this point, we will be able to come to this unique path. Okay, so that is a given. Same goes over here, that no matter how many number of possibilities we have to come to this point, if once we are at here, we are guaranteed that we can come to this point. So in order to reach to this point, the only possible ways are this one and this one. So if we sum these two, we will find the number of unique ways we can reach to this element, and in this case it would be 3. If we continue down the same path for this point, we can take 3 distinct paths to reach over here, and in order to reach to this destination D, we can take 3 plus 3 6 unique paths to get to here, and this actually becomes our answer. Okay, so based on our previous explanation, we know these things. So if we see, now we need to see that how can we use dynamic programming to solve this problem. And the reason we are choosing dynamic programming is because at any single location we are computing that whatever the previous two results that we have already calculated, and we are using them to calculate the next values. So that pretty much indicates that we need to use dynamic programming over here. Now let's take a 2 by 2 matrix, and we'll just provide the index values. So index values would be 0 1 2 0 1 2, and we would name this matrix as DP to refer dynamic programming. Now the thing is, if we want to find out the value at this position, we know that it would be sum of these two elements. So mathematically we can write them like this, that DP of 1 1, because this is 1 and this is 1, is actually equal to DP of 0 1 that we have already calculated, which is this value, plus DP of 1 0, which is this value, and sum of these two will give us this value. So generically we can actually write them like this, that at any given location DP of M and N would actually become DP of M minus 1 N plus DP of N and N minus 1. And this would be our recurrence relation for dynamic programming. And I already explained that why are we choosing dynamic programming. And our aim is to find that how many distinct ways we can reach to this destination. So this destination would actually become DP of 2 over here. And if we compare it with whatever M and N is given, this actually becomes the value over here. This would become the DP of M minus 1 and N minus 1. So we start our calculation like this, and eventually we would reach to this point, and we just need to return whatever we have found over here, and this would be our solution. So we can just create two loops. One loop iterate over the column, one loop iterates over the rows, and eventually we will reach to this endpoint. We return this. This becomes our solution, and this is a very efficient dynamic programming solution. Any FAANG companies, Facebook, Google, Amazon, whatever, they would be happy to hire you immediately. So now let's see that what would be the time and space complexity. So time complexity would be big O of M times N, because we need to iterate over this entire grid. So that's why it's big O of M times N. And space complexity, remember that we are creating this additional DP array, which is 2 by 2 matrix, and we are giving the size as M and N. So space complexity would also be big O of M times N, and this would be our solution. Now let's move on to coding. Okay, first of all, we'll create a two-dimensional array, and we'll name it as DP, and we'll provide the length as M and N. Now we'll have to create our base case, so we'll fill our two-dimensional array, and this is the way to fill a two-dimensional array. And over here now we'll create two for loops, and we'll start with I is equal to 1 and j is equal to 1, because we already have cases for 0, while I is less than m, I plus plus j is equal to 1, j is less than n. Okay, now we will provide our recurrence relation. So dp of I and j at any location is equal to dp of I minus 1 j plus dp of I j minus 1. And yeah, this is pretty much it. This should be working. So now let's return dp of m minus 1 and j n minus 1. Let's try to run this code. Oh, it should be arrays.fill, small error. Looks like our solution is working. Let's try to submit the code. Okay, our solution is actually runs in 0 millisecond. It's 100% faster than all the other submissions, which is pretty good. And I'll be posting this in the comments. You can check it out from there. Thank you.